Aseem. How you doing?
Doing well. How are you?
Doing great. We are looking forward to your presentation on your topic here today, and the floor is all yours.
I'm not actually going to do a demo or a live demonstration. Instead, I'm going to encourage everybody to try it out themselves. There's nothing like using AI in testing yourself. We have a sandbox that's completely free, and we have a free trial that you can run. So when I make claims of what AI can do and provide for you, and you go, there's no way that's possible, try it, and you'll see it actually working in real time. I'm going to talk on two different areas in software testing. The first is from the perspective of user interface testing, and specifically looking at sort of like the evolution of automation testing from traditional automation platforms to AI platforms today. And the second one, which I thought was kind of entertaining, is we did a sort of like a bake-off between using these Microsoft Copilot, Google Gemini, and what we do from a perspective of using AI for API testing, and where each one was appropriate. So that's the two sort of areas. The first, here is a reason why QA is important. Many people at times sort of go, well, it's testing, who cares? Until one of these things happens. These are just epic fails. And I mean, if you look for about 30 seconds, you can find as bad or worse. There's one of our customers had a massive problem in 2017 that was frankly even more expensive than these. My marketing team sort of like pulled out some examples, but what's the real takeaway? You can lose a lot of money if a bug actually makes it into production. And it's not just that your schedule is getting out of whack or your budget is overrunning. You can cripple, and in many cases, actually, in these scenarios, entire divisions have been shut down as a result of an epic fail that cost $440 million in 45 minutes to Knight Capital Group, or $451 million to TSB Bank. So, I mean, testing is important. And frankly, it's getting harder to test over time. I've been building systems. I have a master's in computer science. I'm a developer by background and system architect. And honestly, with systems becoming more and more agile, and with cloud environments, these are all great things from a development perspective. But from a test perspective, the complexity of what's being done is just going up. And the requirements, I mean, one of the clear values of Agile is that requirements change. One of the key problems in testing is that the requirements changed, and releases are getting more frequent. We have many customers that are releasing code per day, not per week, not per month, not per quarter. We have some that do that, but releasing into production on a daily basis. So there's a need for both speed and precision in terms of what's being carried out. And notwithstanding that, test automation is kind of always, I'm sorry, I don't really have a good way to say this, but it was never good. It's been a painful process to make automation work. So what are the areas that you can really use AI to make a difference in the testing that you're carrying out? In UI testing, the bane of automation testers are locators and timeout. From our own internal data across all of our customers, we see isolated locator and timeout changes, not feature changes. Just the locator is broken and the timeout is broken is 40% of the time why a particular test case is not working when a new build comes. What's an AI solution? I'm going to talk a little bit more in depth about this. While the automation is executing, why can't the AI just fix the locator for me? And in addition, why can't it just fix everything, not just sometimes? Self-healing, we've managed to get 70% of locator and timeout changes to auto-fix themselves while the automation is running. And then we have a mode called AI healing where everything is fixed within 24 hours. API testing, there's a lot that can be done with AI when it comes to test case generation, when it comes to self-healing, when it comes to shift-left testing. Mobile testing is an interesting and different space due to device fragmentation, localization that is there. That's there in UI testing too, but I think mobile is bringing it even more to the fore, and it's more challenging because of the device fragmentation. Once again, AI tests that are targeted first towards the features, and second, towards where issues are likely to come between mobile native versus mobile browser applications can really make a difference in terms of how your testing is carried out. And then there's the COTS applications like Salesforce, SAP, Oracle, et cetera, which are complex workflow applications. And their typical test cases are over 100 test steps and validation points. That makes them incredibly brittle and very, very tough to maintain. And some of the systems like Salesforce, even getting locators to work correctly in the first place is tough because of how complex their HTML is. So I'm going to start with one of the more basic QA metrics called defect leakage. Hopefully everybody knows this, and I'm just going to breeze through this, but I found many organizations that don't even measure this. And defect leakage is how many bugs made it to production over how many bugs did you find, right? And if you're doing a pretty good job, you're going to have that below 10%. There's all kinds of ways to manipulate this metric, but if you're not measuring it, you're really not taking a quantitative look at what is the quality of the software that you're deploying into production. This is a build out of the cost of a bug. I think since the 60s, there's been research from IBM that talks about how expensive bugs are, particularly when they're found later in production. You start off with the stuff that most of us deal with in dev teams on a day-to-day basis. Your schedule goes up. You have to do overtime. The project gets delayed because by the time you start testing, because dev is always late, by the time you finish, the schedule's out, then you find more bugs, then you delay even further. But that's actually the good scenarios. The bad ones are you actually push it to production and people look at your software and go, oh no. I think there have been some examples where, even recently in the public, where people have pushed out new builds and literally the company's gone sideways. Service outages are direct revenue impacting for many people, like for example, at Priceline or any of the travel industry portals where, if your site's down, you're not making money. And then there's the cases where you actually get hit with lawsuits for what happened when a defect leaked into production. It's incredibly expensive is the basic point. So what's the solution for this? The solution is comprehensive, up-to-date test automation run in staging. Seems really simple, right? Just run your automation in staging. Unfortunately, the keywords comprehensive and up-to-date are the things that kill you when it comes to software testing and automation. So, comprehensiveness. How do you know that the test suite that has been generated is any good? How do you know that all features have been tested? How do you know whether negative tests have been put in? Currently in the industry, most people basically look at a test case that's written by someone, review it, by someone else reviews it. Sometimes they just take it as good enough, and they use that as the metric. This is one of the areas that AI can really help you. We've actually built AI crawlers that navigate through websites and identify test elements and scenarios so that this picture at the bottom is straight off of our Webomates CQ, which is our testing service. We generate this using AI. It's a test plan, showing you the hierarchy of test cases, and then we generate the actual human-readable test case. We're using web crawlers with AI to actually identify the test elements and the scenarios, and then we're using LLMs to take these scenarios and generate the full test case and validation points. I heard one of the last speakers say this, I'll just reiterate it. You have to check the output from AI, and we are go at extreme lengths to partner with our customers to make sure that they review, approve, edit, modify everything that we generate at this level. Cool thing is, you edit the test case here and you just get the automation and run it. This sounds like science fiction to most of the people I present to. My answer is log in right now, go to webomates.com, play with the sandbox, put your own application in, do a free trial, and try it out. This will be generated for you in 24 hours. The test cases will be generated for you, both of these parts in 24 hours, and the automation 24 hours later for 10 to 15 test cases. If you have questions, keep asking them. I'm going to keep moving forward. So 2 parts to decreasing defect leakage, comprehensiveness and up-to-date. Let's talk about up-to-date. If you've ever written test automation, the problem is not just getting it ready, which is a software project in and of itself, to just get the automation built. The problem is that with every build and every execution, when a new software build comes, the automation software breaks. And the problem with the breaks are it could be a bug, or it could be the automation no longer works. Types of things that break automation in UI are locators, timeout, test data change, environment data change, and here are some of the kickers. The feature changed, or a new feature was added, right? AI can help you for all of these capabilities. We believed in this so strongly that we actually invented a word and copyrighted it called AI healing, where this table down here actually tells you in technical terms what is guaranteed to be fixed in 24 hours using AI healing. Locators, all types. Doing IDs, very easy. Doing XPath, not easy at all. And if you go into our sandbox, you can actually see an example of two builds of software where the two builds are actually different and the locators have changed and the automation continues to work. So locators timeout, test data change, environment data change, and then the really hard ones are the test cases modified. So how does AI help in these cases? We've built a neural network that actually analyzes the output of the automation system and identifies on the fails what the root cause, whether the problem is a bug or a script that's broken. And if it's a script that's broken, what's the underlying root cause? Is it a locator or a timeout? And then actually recommends what the fix is, and in some cases just does the fix. The neural network was trained with data that we've accumulated within our own system over time, but it's 99.92% accurate in identifying in a failed test case why it's broken. We use natural language processing and vision AI to actually analyze. The natural language processing is used to take the user story for the new build that's come. So new build has, say, 4 user stories. We grab the user stories, take the text that's in there, and analyze it to actually identify what are the test cases that are modified and what are the test cases that are being added as a result of this user story. And then we use vision, for example, which is another part of artificial intelligence where you're looking at pictures and compare them to see if at this test step last time in the build, what did the user interface look like and now what does it look like? Then we use LLMs to regenerate the test cases that have been identified as needing fixing, and then from there regenerate the automation in 24 hours. And now you have up-to-date comprehensive automation, which really can make a huge difference on your defect leakage numbers. The second area that really can help is shift left testing. Everybody talks about shift left testing. This is basically find your bugs early, right? Everybody knows the earlier you find a bug, the cheaper the cost of that bug is. You can sort of like dive into it and, do the analysis. But I mean, anybody working on a dev project will say, if I can find it in dev, not in integration, it's better. If I can find it in integration rather than in staging, it's better and cheaper for you. And of course, finding it in production is just a bad idea, finding defects in production. The solution for this is surprisingly the exact same answer: comprehensive, up-to-date test automation. Why? Because if your automation is up to date in 24 hours, well, then you can do what this grid shows. Over here, this is only January, so it says all the bugs were found in development because it was for the first 10 days and there was Epic in development. But look over here, in Q4 in 2024, 2% of the defects were found in development, 13% were found, 15% were found in integration, and 78% in staging. Whereas over here, more than half the defects were found before you even got to staging. If you can find defects earlier using up-to-date test automation, you get transparency, predictability. Transparency because you know what's working, predictability because you know how much is left to be fixed based on the pass-fail reports and bugs, and lower stress because you don't get a massive pileup of defects that occurs at the end of the system. Okay, here's a very quick comparison between using Copilot and Gemini. These are excellent tools to use in dev. And you can look at these slides. They're really good. We spent a good while and we constantly reviewed the updates. In December, Gemini was leading on the unit testing front, which is what we used it for. Really, really good. You can see over here, writing boilerplate code, code generation, code refactoring, debugging, and we gave it an 8 on 10 to use Gemini for unit testing. If you aren't using Gemini or Amazon's Code Whisperer or Microsoft Copilot, please do. It'll make your unit testing life tremendously easier. However, this does not work as well when you start doing actual multi-service test cases. This is a simple API test with a workflow. You can see that prompt time went up to 137 minutes. Then we did a medium to complexity test case, 1,000 plus words, 240 minutes. And you can see the sort of like pages and pages of the prompt that we were trying to do it. It wasn't very good. Authentication was missed, APIs were missed, and it really starts breaking down in that. So basically, use them for unit testing. They're very good for doing that. And that sort of covers everything that I wanted to do today. If you have any questions, start queuing them up now. One last comment. I've tried to put together these cheat sheets that can help you look at the evolution of automation, going from sort of like open source Selenium to cloud automation systems, and what are the capabilities you pick up there versus AI automation systems, and what are the capabilities that you pick up over there. Just go to webomates.com, resources, AI cheat sheet, and download the cheat sheet if you're interested. Similarly, I've summarized a cheat sheet for unit testing versus system and integration testing for APIs. You can see over here the unit testing, Gemini, Copilot, Code Whisperer, all really good for happy days, negative scenarios, but being specific here, this is single service unit testing. Think like method level. You're putting in happy day scenarios, you're putting in negative scenarios. You have a nice block of text that describes your method. The LLM capabilities are super for taking that text and generating happy day scenarios and negative scenarios for testing at a unit test level. You want to do more complex testing, you really need an AI automation system that can generate test cases for you, that can generate automation for you, and that can do AI healing to keep it up to date. You can see again, test data, environment data, regeneration, all starts coming in when you start looking at AI automation systems. So with that, have any questions?
Great job, Aseem. Thank you so much for sharing. Let's see. Yes, we do have a question that came in. The question here, Aseem, is can you share examples how AI has helped organizations that you have worked with improve their time to market?
Absolutely. The first thing is that if you do testing today in this fashion, where you do one cycle where you do development, and then you do one cycle in which you do testing. And normally that's the way it works up, whether you're doing manual testing or you're doing automation testing, you have like if your sprint is 1 month and your dev sprint is 1 month and your test sprint is 1 month, that's reduced to 1 day using AI in your testing framework. We guarantee that we will fix the automation in 1 day. You can dramatically reduce your test time, which then means that you can get to market faster because you're not doing that build one, wait one, because what happens is you build, then you start testing, the bugs start going back, and then in the middle of the next dev build, they're suddenly getting bugs that they're trying to fix and everything starts delaying out. If you know 1 day later that your automation has tested everything and you're good to go, you suddenly will move a lot faster. And shift left testing will make that even superior because your defects are found on developer check-in or at integration test time, maybe on a weekly basis.
And we have another one. Thank you for that. And thank you. That was a great question. Another question here, Aseem, is what is the level of detail that is required for requirements for automation to be efficient? And it's 2 questions, actually. And are these functional or domain level user stories?
So funny requirement for when we generate, the documentation that's necessary is nothing. Nada, zilch, zip. Why? Because how many projects have you worked on where you walked in and someone's like, you're like, can you give me the marketing requirements document? Yeah, we wrote that like 10 years ago and we haven't updated it since. So when we're doing AI generate, which is the creation of the automation, we need access to the system as in HTTPS access, and we need a test account of a role that you want tested, or if it's 3 roles and 3. And the test plan and the test case will be generated based on the user interface itself or on the Swagger document if it's an API. If you have more, we have customers that have fed us requirements document. We've had customers that fed us test cases. The AI sort of like is like a fat cat. When you feed it more, it just goes yum. And the quality of what comes out is even better. So your review and control decreases as the input increases, but we'd go out of business if we required everybody to write everything, Pavani, first. Now, the user story part that I talked about was something that we found almost everybody does. When you're doing the next build, almost everybody is either using Jira or Jira, depending on your pronunciation, or they're using the Microsoft equivalent system to basically track what the dev team is supposed to be working on in the next sprint in the form of a user story. It's just words. It doesn't have to be in Cucumber. It doesn't have to be detailed. It's enough that the human developer that is writing the code is able to understand what the feature is, and we then generate it. The user story is not the only thing. We're also looking at the screenshots between past and present, et cetera, et cetera, et cetera. There's like 14 variables, but the user story is really a good place to start from. And that's where we require that the user story is provided. Did that answer the question?
We have a few minutes here that you have Aseem here to address any questions. Any other questions? Anything else he can elaborate on that he had shared in his presentation, or to any of the other questions that were addressed here? Let's see here. Don't see anything else yet except praises, which is good. So you got a lot of great feedback there, Aseem. So great job there. I would just say in a minute, if you have a minute, Aseem, anything you want to close up with what you shared today that could, just leave the listeners, those here, to take action with what you shared.
I think that it's important to understand what the value of AI is, and also how far it actually goes, because we're running into sort of like 2 kinds of audiences. One audience that doesn't believe anything can be done by AI, right? And the other end is the audience that believes, well, why can't it just generate everything automatically in 30 seconds flat and have it ready for me and it just runs? It's AI. It's weird because I haven't ever worked with the technology, and we've been working with AI now for 8 years, where the expectations from, people going, yeah, you're saying AI, that's just bullshit, it's marketing hype, nothing works, right? And the other end of the spectrum where they just completely believe everything is going to work. You kind of got to take a middle ground. You got to kick the tires. You got to try it out and sort of really validate what are the use cases that AI can work for you. And, it's one of the reasons why we started doing more and more trials in the sandbox, because it's like, see yourself how much it can do for you. Because if you don't do that, you could end up with snake oil, right? It just depends. If you just sort of go, yeah, it's AI, it's going to work. And if you just say, no, it's not going to work, it's AI, I refuse to touch AI, well, you're kind of, trying to use a horse-drawn carriage once the car's been built.
Well, we had 2 more questions come in, but I only know we got about a minute here before we go to break. But if you could address one of them, take the first one that came in. What do you think about using AI testing for complex software integrations, for example, Salesforce that you mentioned earlier in your presentation?
It's entertaining because so a lot of people go, well, it's just a GUI and it's just HTML. Well, the problem is that it's long, complex workflows between modules that have been customized. So you have one problem, it's extremely complex HTML. So traditional sort of like locators tend to break, and you have to be a little bit more diligent to make sure that your automation just works. The second is automation brittleness is directly correlated to how long your test case is. But because the workflows are long, whereas normally our average is 50 to 75 test steps and validation points for doing a test case, in Salesforce, it's over 100 to 150 for any average test, which means that it's going to break way more often, which means that it's way more work to maintain it. And, everything breaks. So that complexity is something that sort of pushes these all of these COTS applications like Salesforce into a different level.
We have about maybe, if you could do this in less than a minute, I think we could squeeze it in. Aseem, last question that came in, how do we differentiate between unit test requirements and integration requirements?
So if you think of this at the API level, a unit test is a method call, right? You know, the classic one that everybody talks about, hello world, let's make that an API, or sum, you know, sum x plus y, right? A unit test would be run sum x plus y with one input for x, one for y, put in a negative number to see if it'll handle that, put in a floating point number to see if it'll handle that. What it won't do is do multi-service. So most backends are composed of many, many services chained together. In integration tests, just testing a single microservice is not going to get you very far like you were doing in a unit test. Many people are using unit tests to do integration tests and system tests. It's an extremely painful way to do things, and your ROI just goes downhill. The more complex the test case that you're trying to do using JUnit or any other unit testing framework, the sort of like more difficult it is. So for integration and system tests, use an AI automation.
Thank you so much, Aseem. Aseem, thank you so much for being here. Wonderful presentation and great job at answering the questions. We thank you so much for being here with us today.
My pleasure.